This is our to-do list. The first two items, scoring an 80% or higher on both study guides, is how you get your points for math lab today. And just like I did for unit 1 around this time, you getting an 80% or higher on those first two things will count as assessment points in math lab. Does that make sense? So, because you already had an hour to work on it this morning, and really they've been available since last week as well. You today now have like another hour to work on those and score 80% or higher. And just like I usually do for your practices, like I'll check in at the end and do whatever problems you still need to see. So like there's really no reason we shouldn't be needing that unless we're just like not advocating for ourselves, asking them to need help. All right, you're in groups so that you guys could talk to each other, and then you have me to help, and we also have like a TA for this class to act as a like peer tutor as well. So there's lots of ways to get help. You shouldn't be spending more than like 5 minutes, maybe. You shouldn't even be spending more than like 3 minutes struggling to figure it out yourself. Keep in mind, tomorrow you have to finish both parts of your test in the same class period. So you shouldn't be spending that long. So yeah, some of you already finished the first one and you already showed it to me. I graded it based on completion. Usually on these days, someone from each class will ask at least one problem from there, and I'll have a key by the end of the day that I post in Schoology, and then you can check to see if you're accurate from that. Or you can ask and I can tell you. But that, hopefully you got done. If not, first priority, complete it 80% or higher, and you'll meet that first goal. The other one, auto grades. You get like 3 attempts automatically. If you for some reason need more than that, then tell me and I'll delete one of your lower scores. But it's the same question each time, so don't like spend so long on something you don't know. Be curious about it. So questions on that? All right, a lot of you already showed me those 2 note sheets that we took in math lab already. I'll kind of read out who hasn't yet, or if you know you haven't yet, then have them out on your desk. I'll be checking that. But then once you've mastered those first 2 things, now those are first priority since we test tomorrow and I'm giving you assessment points for doing them. Then you can move on to the other things that are suggested on this list. Do them in the order that they're listed. Questions? Okay. Yes.
What are the 2 note sheets?
The 2 note sheets we did on our own paper, like I didn't give you a template, but it was for translating expressions.
Like it says, I think the only degree for prime emission. Yeah, that's one of them.
And then literal equation. So 14 on the puzzle piece study guide looks like this. It wants to know the rate of change for each function. What's another word for a rate of change? Slope. So we want the slope of each. So for function A, it's an equation. What's the slope? -5. So that one's in slope intercept form, y equals mx plus b. Slope is always in front of the x term. So even if I reverse this order, if I made it -4 minus 5x, the slope is still -5 because it's in front of the x. Okay, so that one's good. -5. This one's a graph. So slope from a graph. What's the best method to use to find slope from a graph? Rise over run. There's other ones you could use if you like those better. It's up to you. But I agree, rise over run on a graph is easy to determine slope. You need to find 2 points that you could clearly see. They mark some for you. They don't always do that. You could use those 2 points. Or like this one is also easy to see. Just anywhere that it goes through, like what I call like a crosshair, that you don't have to estimate what value that is. So pick any 2 points. If it's on paper, you could draw like a triangle to connect them. Usually the smaller the triangle you make, the less you have to simplify at the end. So I'll connect these 2 points. And then count your rise, and you always count it going from like your left point to your right point. So like how you read. So going from left to right, I do have to go up, so my rise should be positive. How much am I going up? 2. And then for my run, how much is that? 1. So then rise over run, 2 over 1, my slope for that one is 2. And let me just show you while it's here. If you did choose these other points that were already there, just pretend that's a straight line. Then you would still get 2 as your final answer for the slope. But going from this one to that one, I'm going up 1, 2, 3, 4. And then this run is 1, 2, rise over run, 4 over 2 is still 2. So just pick any 2 points that you can clearly see, and you can do it that way. So function B, that rate of change is 2. Then on function C, we have an input-output table. So with that one, rise over run probably isn't as helpful. I don't think you're necessarily going to graph each of these by hand. You could put them in Desmos and then see what the points are and do it from that graph, but even that can be tricky, like if you zoom too far in or out. When it's from a table, I recommend either of these two, y2 minus y1 over x2 minus x1. It still gives you slope. It's rise over run, change in y over change in x. For a table, I think this one might be better. So pick one of your coordinates to be x1, y1. I'll pick the first one. And then another one to be x2, y2. Shouldn't matter which ones you pick. Just as long as you label them, like x's should be x's, y should be y. Should be the same pair for each like set. So the way that I labeled it like this, on top it would be 3 minus 0, because y2 minus y1, over x2 we're saying is -5 minus x1, which is -6. That's what it looks like before I've done any simplifying. And then you simplify. It's 3 minus 0. Three. And then -5 minus -6 is what? It is not that either. Feel free to use a calculator for that. +1. All right, because what happens with this double negative? So I would add the opposite, -5 plus 6 is 1, and we can check that on the calculator too. So for function C, my slope is 3. And then it says function blank has a greater rate of change. So let's see, this one was 3. This one was 2. The other one I remember was negative, so definitely not that one. So which function is the greatest rate of change? So then that's what you should put for that one. And then I'll just make sure it marks the right answers, and sometimes there are mistakes. But what we did together is not a mistake. So yeah, that's marked the right way. So questions on this one? All right, questions on others? It could be your constructed response practice, it could be a puzzle piece, a question, it could even be the optional study guide, and give you extra credit for them. Any questions? You don't have to ask questions. If you already know it, then great. Number 7. Okay, so we're graphing a system and we want to identify the solution. So. I know you can type things in Desmos, but just also know that you have to graph it by hand on your constructed response. So I'm not even gonna bother showing you with Desmos, okay? I know you probably know how to type things in. And then the solution would be what for a system? Where the 2 lines intersect. So it looks like this is saying that it intersects at a coordinate. You would put the X here and the Y there. Yeah. Okay. Is that all? Does anyone have a question about this one? Do you want to see how to do by hand? For your constructed response? All right. So for your constructed response, because again, I can tell when you just copy it from Desmos because it usually doesn't actually line up the right way. When you're graphing by hand, what form is probably best to use? Well, that would be solving it by hand. If I want to graph it by hand, I want my equations to be in what format? Good. Because when it's in that format, I can clearly see what 2 things? And those are the 2 things that I need to figure out where my points go. So that's why we rearrange it to that form. And in order to rearrange it, you're basically just getting the Y alone because that it's alone in slope-intercept one. So over here, what would I have to do to get the Y alone? You would have to subtract X, whatever you do on one side of the equal sign. Now are 24 and X like terms? So then the Y is alone, it's already in slope-intercept form. I will just switch the order so it looks more like MX plus B. But as long as you know slope's always in front of the X, you can even see over here, my slope is -1, my Y-intercept's 24. So then on my graph, I would put a point at my Y-intercept. Wherever 24 is, let's pretend it's like right here. And then I use my slope to plot my next points. So what's my rise over run for this slope? No. If it's -1 in front of the X, I know the one's not written, but it's implied. Then what's my rise? And then what's my run? Well, what's my rise? Am I going up, down? I'm going down how much? 1, and then what's my run? 1. Your run should always be positive. Like your rise is what's affected by negative. So that's my rise over run. So from my Y-intercept, I would go down 1 to the right 1. And of course, my time decides to be up now. Go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. Make sense? And then for the other one, arrange it so that the Y is alone. What would I get rid of first? The 2X, how would I get rid of it? No, subtract it. Good, do it to both sides. I get -Y, so is the Y alone? Not yet, because the negative needs to now go away. And then to make it look more like MX plus B, I changed the order. But the 2X is still negative like it was over here when we subtracted it, and the 6 is still negative. Now, how do I cancel out this negative that's next to the Y? Right now it's -1y, so -1 times y. Opposite of multiplying -1 would be. And whatever you go on one side. And then remember to do it to both terms on the other side. So now the y is alone. What's my slope now? Gonna be? +2. And then what's my y-intercept now gonna be? Good. And then you would also graph it on your coordinate plane. Let's pretend 6 is right here. So that would be 24, right? And this time my slope's positive. So what's my rise? My slope is 2. So my rise is then gonna be 2, and then what's my run? No. What's my run is the question. So if my slope is 2, my rise is 2, my run is 1. So if it's a whole number for your slope, your run is 1. You still have a run. You just have to make your slope a fraction. You make any whole number a fraction, that's how you get over 1. So then that means from my y-intercept, I would go up 2 to the right 1, up 2 to the right 1, and so forth. And you would see where they intersect. Questions on this one? Okay, questions on others? We might have time for one more. So then make sure that you're scoring 80% or higher, might take you a few attempts. Make sure that after school today, probably is when I'll have the key up for the constructed response. Make sure that you check your work, make sure you're accurate. So far, I only graded on completing it, so you don't actually know if you're accurate unless you ask or you view the key later.